So this is now the lecture. Welcome everyone to a lecture on linear ordinary differential equations. So I'm Oscar Benjamin and I wrote this with Cameron Hall. While we're here looking at these slides, I can draw over the top of them. So we're talking about differential equations here. So if I use my graphics tablet, so a differential equation looks like dx by dt equals f of x t. Okay, and if you watch the generated video of this, you'll see that it's quite jumpy, so these lines don't appear smoothly on the output. And that's the same thing when you're using the whiteboard function in Blackboard Collaborate. So that's why I've got an external program for that. So I come down to the next slide. So everyone, today we're talking about ODEs. This is the stuff we looked at last week. And now, right now, what's most important is whether ODEs are linear or non-linear. And I'm going to draw over the top here. So look, this one is linear. Okay, so that's very important. I can also highlight things using, where is it, the pointer. So this pointer makes a little hand that people can actually see on the video. Otherwise, my cursor is not visible on the recorded video. Okay, so that's all of that. So that's how we go through the slides, and we could talk over the video and do the lecture like normal. Of course, every now and again you're going to want to be able to demonstrate something to break out onto a whiteboard. And so from here, if we go back, then I choose whiteboard. So now there's a whiteboard on the screen. I can use my mouse to try and draw on it, and that looks not very good. Or I can use my graphics tablet, and I can say y equals e to the x, and it's all coming out. It's not coming out very well here. Let's try that again. Y equals e to the x. So I really don't like this whiteboard within Blackboard Collaborate. So I will close that. So from here, if I want to go back to the lectures, I have to go back to share files, I have to choose that, hit share, and then go and choose a slide again. So it's forgotten where I was in the lecture slides, which is quite annoying. I come back here, so now I'm back to the lecture slides, and that's what will be seen on the output video. What I've found is the OpenBoard program is a better way of demonstrating equations and things. So if we come back here, back from share files, and we do share application on screen, and here I should be able to set particular programs, but on Linux it only seems to allow me to share either a tab or the entire screen. So I'll just share the entire screen. And now I can switch over to using OpenBoard. So here today we're talking about differential equations. So that's an equation that looks something like dx by dt equals f of x t. The particular kind of differential equation we want to talk about is something like d2x by dt squared plus 3 dx by dt plus 2x equals 0. And we know that we solve this using the exponential answer. So x equals e to the lambda t. And we're going to substitute that into the differential equation, but we also need to find out what dx by dt and d2x by dt squared are. So dx by dt, I can just differentiate this right-hand side, is lambda e to the lambda t, and d2x by dt squared is lambda squared e to the lambda t. If I substitute all of that in here, I will get lambda squared e to the lambda t plus 3 lambda e to the lambda t plus 2 e to the lambda t. So what you'll notice, it takes quite a lot of getting used to using a graphics tablet, but I think once I get the hang of it, this will look fairly good. So then all that's equal to 0, so I've taken out a factor of e to the lambda t, and that's never 0, so I can ignore that. So now I have lambda plus 2, lambda plus 1 equals 0. I can take this, I can carry this over to a new board. So I select that, I'll choose add to new page. I can put that up here, and then I can go back to writing again. So therefore x equals, so I just got it wrong. Let's try that again. So x equals a e to the minus 2t plus b e to the minus t. Now at the end of all of that, I can, so after the lecture, for example, I could go to documents here and I can export these boards as a PDF. So I can do export to PDF, and that will go on my desktop as 1812. And so then if I go to the desktop, so I can close Open Board now, and if I minimize this, whoops, get this out of the way, and then this is the generated PDF file, which I could then share on Blackboard with the students. And this bit that I cut is black and white, where the rest is white and black. I'm not really sure why that happens. But I could upload that for the students to see after the lecture is finished or after I've finished recording. So coming back here to Blackboard, so that was me demonstrating something on Open Board. I'm still sharing my whole screen in the video, which is probably not what I want to do for too long. I could come back to the slides by going here. So I'm going to end the recording now. So within Blackboard, so I'll